Yeah, and yeah, so you do. Yeah.
My goal is that we, finish the lesson, lecture, whatever, in the next 15, 20 minutes, so then you have the last 25, 30 minutes of class for work. So you already have both worksheets and have seen both worksheets that we're going to have done, for lesson 6.1.6.2, or 5.1 and 5.2, excuse me. So you have a pretty good idea of what we need to get done. But we're kind of backtracking and course correcting and looking at 5.2 today, which will make the worksheet from yesterday make so much more sense. So that's cool. 5.2, the properties of rational. We talked about what rational means yesterday, right? Just to be represented as a fraction. Rational exponents and radicals. So even some of the stuff we saw in the worksheet today will come up in the lesson today. So a lot of stuff that's being recycled. Our learning targets: students will be able to use properties of rational exponents to simplify expressions. Some of the properties of exponents that we have already seen in Algebra 1 and that we'll see again today are things like, and that we talked about yesterday even. A to the n times a to the m would give us a to the n plus m, right? That's what we're talking about when we're talking about properties of rational exponents. So a lot of things that you've seen before. Second learning target: students will be able to use properties of radicals to simplify and write radical expressions in simplest forms. So not only are we looking at stuff with exponents, but looking at some things with radicals. This is like I said yesterday, and adding this stuff to it is like 4 or 5 lessons in Algebra 1. But we are trying to cover it in 2, and then add some stuff to it. Order of operations terms. Do we actually have to hear them? I think we have to hear them. But example practice. Bless you. So here is, and I know it's a long, big list. Don't feel like you need to write every single one of these down because they are a review and some things that we have already seen. So I'm just going to start talking about. These slides are posted, they should be posted.
I can't get to the slide.
I'll fix that later. Okay, I'll fix that right during our work time after the lesson. I'll just highlight each one of these. Okay, product of powers we just talked about. We have the same base, then we just, and they're being multiplied, we just add our exponents. That goes for fractions as well. So if we have a to the 1/5 times a to the 2/5, we could just add those together, and it would be a to the 3/5, right? If they don't have a common denominator, then we would have to get a common denominator and go through all that stuff. Power of power. If we have an exponent to another exponent, like we have seen in a lot of our problems, then we multiply them, right? So if we have, like it says, a to the, let's just see here, 32 to the 2/5, I think was the one we saw in the homework. We can rewrite that as, or what we did in the homework was rewrite that as 32 to the 1/5 times 2, right? That's how we did it in the homework. We are allowed to do that because of the power of a product. The power of the product, or power of power, would say that we can take this 2 and multiply it by 1/5 to get back 32 and 2/5. So we've already been using that rule, but kind of in reverse. Power of product. We have 2 numbers inside parentheses. We need to make sure that we give that power to both the b and the a, right? The really common thing for people to do is to rewrite that one like this and not give that power to both numbers in the parentheses. So we need to be careful and make sure we give those to both numbers in the parentheses. Are these looking familiar?
Yeah.
I know we've been using them in the last 24 hours or whatever. So hopefully that helps. Negative exponent, like we talked about. Negative exponent does not mean negative number. Negative exponent means really small number. So first thing we want to do when we see that negative exponent is put it in the denominator and have 1 on top. 0 exponent, anything to the 0 power gives us 1. Quotient of powers. I don't think we saw any of that on our worksheet that we started today. But like it says, we have a to the, let's say, second power, a to the fifth. A to the second just means that we have a times a on top. A to the fifth means we have 5 a's. So we can cancel them out or subtract them, like it says, and then we can just write the left papers. So we're subtracting m minus n, so that top number minus whatever that bottom exponent is. Last one, power of a quotient. We have a quotient or a fraction really in our parentheses. We need to make sure we give that exponent to a and to b, so both the numerator and the denominator are allowed to have that exponent. So let's why don't we try to do these together? If we look at the first one, we are using the power of product rule, right? The first rule, like we said, it works all good with fractions. We have to rewrite one of these fractions. Which one would we probably want to rewrite? We need common denominators, right? So we probably want to rewrite that 1/2, like I think Ryan wanted. So our base stays the same. 1/4 plus 1/2 gives us 3/4. Now, part B, there's a little more to it. What would we want our first step to be in part B? What do you think? Our first step.
Distribute the squares.
Yeah, we want to probably just distribute that, that 2. So that would give us 6, let's see, 1/2 times 2 just gives us 1. Not anybody's way. 4, let's see, 1/3 times 2 gives us 2/3. Now, you could, 4 to the 2/3, I mean, if we just think about this for a second, 4 to the 2/3 would be 4 to the 1/3 squared, right? 4 to the 1/3, is there anything that we can multiply together 3 times to get 4? No. So you could put that in your calculator and get some decimal. What I would look for on the homework is your answer would be 6 times 4 to the 2/3, and that would be okay. Right? Unless it specifically says like round to the nearest tenth or something like that. And just to leave it in this form would be all good. Part C. What do you think our first approach? There's a couple of different ways we could do it, but someone help me out. What do we think our approach could be? Like this? Yeah, that would work. I mean, we can see pretty quickly how we can 4 to the 5th, 3 to the 5th, and multiply them together. We'd be working with real big numbers, but we could simplify that, especially if we just use our calculator to multiply those. And I won't go through all of that because I can do it. Let's see. Why don't we skip letter D and we will look at the last one, letter E. What do we think? What would be a way to start solving? We can move that up so people in the back can see. Start solving letter E.
Power of a quotient.
Yeah, power of a quotient. Could work. Now,
Distribute the square.
now that would work, but that doesn't really help us simplify a whole lot.
Can't you just get rid of the 2/3 because they're both the same on top and bottom?
Yes. So it wasn't necessarily, this isn't wrong. This is not incorrect, okay? You definitely can do this. How the textbook would show you how to do that first, how to do this one, what the textbook would tell you is to rewrite it as 42 over 6. to the 1/3 and then that whole thing squared. It's kind of our power of a product rule, except in reverse. So since they are both to the 1/3, we can take that 1/3 and put it right here, right? Because our power of a product, or power of a quotient, I said power of a product the first time too, didn't I? Power of a quotient rule says that this can go here and go here, so they kind of want you to work it in reverse. So they're pulling all kinds of tricks on you. They are. Now, do we know 42 divided by 6? 7. And this is why, this is kind of your key. You're thinking, well, why would I not do what Levi said? That's the first step, and that's what our rule said to do, right? Is to give the 2 to the top and the bottom. Kind of your key that you maybe want to take that 1/3 out first would be that we can divide that 42 divided by 6 comes out clean, okay? Now, you still could get the same answer. So we would have 7 to the 1/3 squared. To totally simplify it, we would just say 7 to the 2/3. So if you went the route that Levi did over here, we could see that they both have a 2/3. I think this is the way that Ryan was leaning too. If we wrote it as 42 over 6 to the 2/3, we still would get to the same spot. Do we see how we're using the quotient rule kind of in reverse? To take that 2/3 or take that exponent out? On a scale of 1 to 10, are we confused? Are we okay? Yeah?
So since it's the 2/3, so they don't cancel out.
They wouldn't cancel out. No. Nope. Because 42 to the 2/3 is going to give you much different, right, than 6 to the 2/3. That's a good question, because a lot of times we cancel stuff like that. So that was our stuff with exponents. Those were our rules with exponents. Now we're looking at a couple things with radicals. And these are both things that you have seen before in Algebra 1. I think this is the last thing to look at, and then I forgot, we get to look at okay. Really quick, some properties with radicals that you've seen before. Product property with a radical says that if we have something like let's say like this, the cube root of 7 times 14, we can rewrite that as the cube root of 7 times the cube root of 14. Okay? That's what the product property tells us. That's something that we did see in algebra, but it was only with like square roots. Alright? It wasn't with cubes or to the fourth or fourth root or anything like that. Quotient property. As you can imagine, same idea. If we have a fraction or quotient inside of our square root, we can rewrite it as the square root or the nth root of A over the nth root of B. I think we have an example, but just because of time, we're going to skip the example. Do get plenty of practice on the homework from yesterday. We have 3 conditions. I get you guys have probably thought to yourself before, how do I know if these are in simplest form or not? Right? Who's thought that to themselves? How do I know if this is in simplest form? Trey asked once or twice. Here are the 3 things, kind of our 3 checks, right, if something is in simplest form or not. Firstly, no radicants, so that just means like our radicals are square roots. No radicants have a perfect nth powers as a factor other than 1. And you're probably thinking, what the heck is that? Okay? Let's think back to our algebra days again. So last year, or maybe a lot. If we had something like the square root of 100, how did we, oh, sorry, not square root, that's the square root of, let's go 100 multiply the square root of 200 last year in algebra?
Square root of 10 times square root of 20.
I don't know. Square root of 10 times square root of 20?
Square root of 4 times square root of 20.
I like the guesses, and you guys are close. So if we saw this back in algebra, we would want to think about what numbers can we multiply together that give us 200, where one of them is a perfect square. So if you saw this back in algebra, we would have written 100 times 2, right? 100 times 2 gives us 200, correct? Right? 100 times 2? Okay, cool. Let's make sure we're good. So what you would have done in algebra, said, okay, the square root of 100 times the square root of 2, that's one of our properties we just looked at. Our answer would be 10 square root of 2. Okay? So that's what it means here in this first step. That we would not leave something as a square root of 200. We would break it down, or a cube root of 200, or whatever root it is. We would break it down and get whatever perfect square we can out of it. Or perfect cube. That's what it means by the perfect n. It might be a perfect square, it might be to the third power, fourth power, whatever. No radicants contain fractions. So nothing like the square root of 7 over 12 or whatever. Those are the first two rules. Third rule, no radicals appear in the denominator of a fraction. We don't like square roots in our denominator. So does anyone remember what it's called when we take the square root out of the denominator? It starts with an R. No. No. Faith?
Numbers.
Rationalize.
That rationalization.
No. Rationalize the. Yeah, good job. We rationalize the denominator. Yep. When we have a square root on the bottom, we rationalize the denominator. We hate square roots on the bottom. So if we had something like 2 over the square root of 8, we hate square roots on the bottom, so we rationalize the denominator by multiplying by square root of 8 over square root of 8. Do we remember that? Yeah.
Sure.
We get that square root out of there. So those are how we know something's all the way in simplest form. Those three conditions are met. Which, I think we have a pretty good eye for that kind of stuff, but that's just putting it in like, boom, there's the rule. I think this is our last new concept. Yeah. Yep, we're going to skip those practices. We're going to straight to worksheet. Last new concept. Hang with me. I know, I said 20 minutes and then 20, so I'll do a couple minutes over. For a denominator, that is a sum or difference involving square roots. So like this. If this were on the denominator, maybe over 6, and this one is over 6. The denominator. This is one square root. Multiply both the numerator and the denominator by the, is this a new word, conjugate, or have we seen that before? We've seen that before. Oh, we've seen that before. So I don't need you to go through this slide?
Yep.
Actually?
Yep.
Yeah.
Actually, I do, or actually it's coming?
I don't think you.
Oh, I do, okay. Multiply by the conjugate of the denominator. The expression, all that stuff, are conjugates of each other. So, as we can see, conjugate, the only difference is one's plus, one is minus. I will show one quick example of this, because I think an example would be a lot more helpful on this slide with this concept. So this kind of goes with the idea that we don't like square roots on the bottom. They're presenting an issue where if we had something like, well, I can just write it right here. If we had something like this, 1 over 5 plus the square root of 3. That's an issue because we have a square root of 3 on the bottom. And just multiplying by square root of 3 over square root of 3 would not solve our problem. Okay? So we multiply by the conjugate. So based on that slide, does anybody know? Let's go from the middle row. Anyone from the middle row? Can you tell me what the conjugate of 5 plus square root of 3 would be? Come on, 5 plus the square root of 3. We multiply by 5 minus square root of 3. And that is how we would get rid of the square root on the bottom. I mean, you might be thinking, wait a minute, how do we simplify this? I'll show you. Yeah, I can read mine. We haven't noticed that. So this is what we'd have on the bottom, correct? Right? Now, if we were to, does anyone remember how to FOIL?
Yep.
Yeah. So let's FOIL. First would give us 25. Would give us minus 5 roots of 3 plus 5 roots of 3.
Those cancel out.
Minus 3. All over 5 minus root. No, not 2. Now look. Minus 5 roots of 3 and plus 5 roots of 3 cancel out.
Oh.
So we are left with
25 minus 3 is just 23.
Okay. I can do that. That's doable.
Look at that. You guys see? No, Cole, we should be applauding you after the game I watched last night.
Oh yeah.
That's cool.
Okay. But actually, do we kind of see what the conjugate does? How that gets rid of that square root on the bottom? Okay, we have practice on any homework. So if you lost the homework sheet, I can get you a new one. But that's what I'm trying to decide because people like already did the odds. So I don't want to make them.
You had 8.
All right, you can stick with doing either the odds or the evens, but I want you to recheck the ones that you've already done because we learned stuff yesterday. So recheck the ones that you've done. Oh, okay. Or did I kick them out?